Hello everyone, this is Haiding Tian, your Math1314 instructor. In this video, we will learn Unit 1, Unit 1.1, Factoring Review. A factor is a number that divides another number, leaving no remainder. For example, 8 equals 4 times 2. So 4 and 2, they are the factors of 8. And what's the other factors, or what all the factors of the 8? So 8, let's list all the factors. 8 equals 1 times 8. And also 8 equals 2 times 4. So 1, 2, 4, 8. They are all the factors of 8. Second example, find the common factor of 4 and 8. We can list all the factor of 4. So they are 1 and 4. And 2. 2 times 2 is also 4. So 4 equals, the factors of 4, they are 1, 2, and 4. And the factor of 8, they are 1, 8. Also, I know that 8 equals 2 times 4. So the factors of 8, they are 1, 4, 1, 2, 4, 8. And the common factor, they are 1, 1, 2, 2, 4, 4. So the common factor, they are 1, 2, and 4. Here is the definition. What is the GCF? GCF means greatest common factor. So the greatest common factor from 1, 2, and 4 is 4. That's the greatest number from the common factors. So let's see the example. Factor out the GCF of each polynomial. For example, the first one, we have 18x plus 27. What is the GCF from the first term and the second term? So 18, the factors, they are 1, 18, and 2, 9. What else? 3, 6. I think that's all. I can't find any other factors of 18. How about 27? 27, I can have 1 and 27. I need to have more space. And what else? Is 3, 9. That's all, right? What is the GCF? The common factor is 1, 3, and 9. So the GCF is 9. So if I want to factor out the GCF, 18x is, I know it's 3 times 9 times x. 27 is 3. Oh, sorry. 18 is not 3 times 9. It's 2 times 9. 2 times 9 is 18 plus 3 times 9 is 27. So if I want to pull out the GCF or factor out the GCF 9, in the parentheses, we have 2x plus 3 left. Okay, let's move on to see next example. We need some more space. So let's clear this area. So the GCF from 3 and 6, I can factor out the 3 because I know 3 equals 3 times 1, 6 equals 2 times 3. So the GCF is 3. So how about the x part? I know that x squared is x times x, and the x is x. So the GCF from the x squared and x is x. I can factor out the x. So we have x left because I pull out or factor out this x. So we have this x left. X plus 2. How about next one? Next one, we have 3 terms. Let's start from the numbers. 9, 18, 27. The factor, the GCF, greatest common factor from the numbers. 9 equals 1 times 9. And, or 9 times 1. 18 equals 9 times 2. 27 is 9 times 3. So GCF from the numbers is 9. How about the variables? Variable is an unknown number, x. X to the fourth. X times x times x times another x. X cubed is x times x times x. X squared is x times x. GCF is x squared. So 9x squared. So what's left from the next to the fourth? If I factor out the x to the x squared, I have x squared minus 2x plus 3. That's it. Because we factor out these two terms, so what's left here? Okay, let's see next one. We have number 7, x times x plus 5 plus 3 times x plus 5. So we directly we see this one. This is a GCF, greatest common factor. So I can factor out x plus 5. X plus 5. We have x plus 7 left. We read them in another parentheses. And let's see. Number 9, the GCF is x minus 3. We can factor out x minus 3. We have x squared minus 12, plus 12. Here is plus. You cannot change the sign between them. So let's see next one. X cubed minus 2x squared plus 5x minus 10. Now, if you see 4 terms, we use group factoring. That means we can factor the GCF from the first twos and last twos. So from the first two, x cubed minus 2x squared, the GCF is x squared, because I can factor the lowest term of the variable, and then what's left in the parentheses? We have x minus 2. And factor out the GCF from 5x and negative 10. That is positive 5x minus 2. Both of them have the x minus 2. We factor out the x minus 2. We have x squared plus 5 left. Next example, group the first two and the last two. So factor out the GCF from first two, we have x squared, x minus 1, plus, so factor out the 2 from these two terms. We can have x minus 1. Then we factor out the GCF, x minus 1, x squared plus 2. And remember that we do the group factoring. You see these two must be the same. If they are not the same, the GCF, they are not same, you may have some mistake. So go back to your previous step to check if something wrong, if you didn't factor out the correct GCF. Let's see, next one, factor out the GCF from the first two and last two. So 3 and 2, nothing in common. We cannot factor any GCF from number part, but from the variable, we can factor out x squared. We have 3x left, minus 2. Minus from negative 6x plus 4, we can factor out the 2 because they are all even numbers. We have 3x. If I factor out the negative 2 from negative 6, we can get a positive 3x. Yes, they must be the same. And if I factor out the negative 2 from positive 4, we know that positive 4 equals negative 2 times negative 2. If I factor out the negative 2, I have the negative 2 left, minus 2. Factor out the 3x minus 2, we have x squared minus 2. Okay, let's see next one, following review. So if I have the multiplication of 2 binomial, how to expand this? So I can distribute the x first. to the next parentheses, x times x times 5. We have x times x is x squared. X times 5 is positive 5x. 4 times x, and then plus 4 times 5. 4 times x is 4x. And then 4 times 5 is 20. We have x squared plus 9x plus 20. Okay, here is the question. If I have this polynomial, can you give me the factored form? How to find the factored form? Here is the A and M method. What is the A? What is the M? A means addition, and M means multiplication. So in the middle term, the coefficient of the middle term is 9. Is the addition? We can put an A here. And the 20, the last term, is the multiplication. So if I want to convert this part, the trinomial, to the factored form, into the form of x blank multiplied by x blank, I need to find what is this here. So the multiplication means the multiplication of two numbers. Addition means the addition of these two factors can make a 9. So what is that? The multiplication of two numbers. I put question mark here, question mark 1, question mark 2. Find the multiplication of 2 question mark make a 20. Addition is 9. They must be 4 and 5. Because addition of 4 and 5 can make a 9. Multiplication can make a 20. So I can put positive 4 and positive 5 here. Yes, we use A and M method to create, convert the polynomial from the expanded form to the factored form. So first identify what is the A, what is the M. So let's do it again. The number 17 is the same question. So I put an A above the 9 middle term. This is addition. And M multiplication is 20, the last term, that's constant. So first step, I will list the multiplication 20 and find two factors. Multiplication is 20, addition is 9. They must be 4 and 5. Second step, write them into the x blank multiplied by x blank. They must be positive 4 and positive 5. Let's use A and M method to solve the rest examples. So first step, put the A on the middle term, put the M on the top of the constant. Okay. Next step, list the M. So M is negative 36. Find the two factors. So multiplication of two factors is negative 36. Addition can make a negative 5. So one of them must be negative because negative times positive is negative. So can I try 4 and 9? They are good because the difference between them can make a negative, can make a 5. So one of them must be negative. 9 is negative because 4 plus negative 9 is negative 5. So I can rewrite them into the x plus 4 and then x minus 9. So the factored form is x plus 4 and times x minus 9. Let's see next two examples. Put the addition or put the A on the top of 4 and put the M on the top of negative 45. So the multiplication of two numbers is 45. And addition, they are 4. So one of them must be negative. I don't know which one is negative. Let's see. So I know that 5 times 9 can make 45. And addition of them is positive 4. So 5 is negative. 9 is positive. The sum is positive 4. Rewrite them into the x minus 5 times x plus 9. And next example, put the a on the top of negative 13, put the m on the top of 14. So multiplication of two numbers can make a 40, and the addition of them can make a negative number. So multiplication of two numbers can make a positive 40, both of them positive or both of them negative. We can make addition negative 13, both of them negative. So they must be 5 and 8. You can also try 2 and 20, but that pair doesn't work. So we try negative 5 and negative 8. Addition of them can make negative 13. So we rewrite the polynomial into the factored form. They are x minus 5 times x minus 8. Okay, if you don't understand or you feel it's so fast, you can go back to listen again, or you can email me, or you can join the office hour online. Okay, let's see the AC method. The previous one, we are using A and M method. So we know that A means addition, M means multiplication. Now we use the lowercase a and c. A is the coefficient of the leading term, and C is the constant, that's the last term. The AC method, we are using the coefficient of the leading term is not 1. The previous example, they must be leading coefficient 1. You see, 1 here, 1 here, 1 here, 1 here. And the AC method, so AC method we are using in the polynomial, the leading term is not 1. For example, this one is 2. So A is 2, C is 6. So how to use AC method? First, multiply the leading coefficient and constant. That means multiply A and C. So A is 2, C is 6. 2 times 6 is 12. Second step, find two numbers such that their product is equal to the result from step 1. That means first find A times C is 12. Then find two factors of the 12. The addition of these two factors can make a 7, can make a middle value. So what are they? So addition of two factors, there are 7. Multiplication is 12. It must be 3 and 4 or 4 and 3. It doesn't matter. The order doesn't matter. So the example said 4 and 3. Second step, replace the middle value with the two values from the step 2. Number 4, factor by grouping and check. So let's see. The third step, we found the two numbers are 3 and 4. That means we can break down the 7x into the 4x plus 3x. Now we have 4 terms. We can do the group factoring, group first 2 and last 2. First 2, they are 2x squared plus 4x. Last 2, they are 3x plus 6. And then factor out the GCF from first 2's. They are 2x. And then we have 2x plus 2 left. Then factor out the GCF from 3x plus 6. We have 3 here. Then factor out the GCF x plus 2. We have the factored form of the polynomial. And then check the answer by FOIL. Then we have the same polynomial. Okay, let's use the example to sharpen your skill. Let's see. Can I use A and M method to solve this one? No. because the leading coefficient is 2. I'm using AC method. Here is my A, here is my C. So A times C is 2 times negative 12. I can move them another side, leave more space. So A times C is 2 times negative 12 is negative 24. Find two factors of negative 24. Make it bigger. So addition can make a 5. What are they? 2 times 12? No, addition is not 5. How about 4 times 6? No, I cannot make a 5. How about 3 and 8? Yes, the difference is 5, and multiplication can make a negative 24. So one of them must be negative because addition is positive. So smaller number is negative. Negative 3 times 8 is negative 24. And addition is 5. So next step, I can break down the 5x into negative 3x plus 8x. 2x squared minus 3x plus 8x minus 12. So group first twos and last twos. So factor out the GCF from the variables because 2 and 3, nothing in common or no common factors, or only one is common factor. There's no use to factor out the 1. So let's factor out the x. We have 2x minus 3 left plus 8 and negative 12. I can factor out the 4. We have 2x minus 3. 2x minus 3 multiplied by x plus 4. So we factored this polynomial. And next one, A is 12, C is 3. So A times C is 36. Find two factors. It's so tiny. Make it big. So find two factors. Addition can make a negative 13. So what are they? You can try 2 and 18. No, they don't work. How about 4 and 9? Yes, that works. Multiplication is 36. And how about addition? Addition is negative 13. So both of them negative. So multiplication can make a negative and addition can make a negative. So break down the middle term into the negative 4x and negative 9x. 12x squared minus 4x minus 9x minus 3. So first two, last twos. Factor out the GCF from 12 and 4. They are 4x. We have 3x minus 1 left. Then minus, factor out the 3 from the numbers, negative 3. So we have 3x. Oh, sorry. Don't copy down the wrong sign. Minus 1. Why I should say minus 1? Because if I factor out the negative 3 from 3, I have a negative 1 left. Then factor out the 3x minus 1. We have 3x minus 1 times 4x minus 3. So here is the question. I know that multiplication of 36 is negative 4 times negative 9. If when I break down the middle term, for example, I copy down the question 12x squared minus 13x plus 3. I break down the middle term. The order of the negative 4 and negative 9 different. So we have minus 9x, then minus 4x. Will the result be different? No different. No difference. So let's see if they have the same result. Factor out the GCF from the first two. We have 3x. Then what's left? 4x minus 3. Then minus, so negative 4x plus 3x. I really want to make a GCF 4x minus 3, a positive 4x minus 3. That means I must factor out the negative sign from 4x. We have 4x, positive 4x left, then minus 3. Continue to factor out GCF, 4x minus 3. We have 3x minus 1. They are the same result. Why? Look at, oh, it's sick. Okay, look at this. These two parts, they are multiplying, and these two factors, they are multiplying. So the position doesn't matter, A times B or B times A. 3x minus 1 times 4x minus 3. 4x minus 3 times 3x minus 1. They are the same thing. So it doesn't matter if you have negative 9 times negative 4 or negative 4 times negative 9, because the order doesn't matter. Okay, let's move on. Okay. If we have the form of a squared minus b squared, we don't need to use any other formulas. We use conjugate formula. A plus b times a minus b. We call this conjugate formula. Okay. Let's see the example number 39. X squared minus 16. Is this, can we use conjugate formula? Yes, because the first term is something squared, and second term 16 is also something squared. X squared minus 4 squared. So A is x, B is 4. So this one equals x plus 4, x minus 4. Next one, is this expression A squared minus B squared? Yes, because 4 equals 2 squared, x squared. Then, and also 25 is 5 squared. The first term is 2x squared minus 5 squared. That is A squared minus B squared. So we have 2x minus 5, plus 5 times 2x minus 5. Okay, let's see perfect square polynomial. Look at the definition here. So if we have x squared plus 2ab plus b squared, you can factor that into the a plus b squared. If we have a squared minus 2ab plus b squared, you will have a minus b squared. So if I have the trinomial, 3 terms polynomial, you must know that the first term and last term, they must be something squared. And in the middle is positive or negative, 2ab. Then you can get the factored form, a plus b squared or a minus b squared. Let's see the first example. The first term is x squared plus 8x plus 16 is also 4 squared. So let's check if the middle is 2ab. So 2 times a times x times b. Is that 8x? Yes, it is. That means we can write them into the x plus 4 squared, because here is plus. So here must be plus. Okay, let's see next example. Can I use the perfect square formula? Yes, because the first term is x squared and 12x. The last term is 6 squared. in the middle, if we have the 2 times A times B, that is 12. And here is minus, that means we need to have a minus in the parentheses, x minus 6 squared. Next one, 4x squared, that's the 2x squared plus 4x plus 1 squared. So in the middle, 2 times A, 2x times 1, is that 4x? Yes, it is. So that's a perfect square. That's 2x plus 1 squared. Okay, last two examples. Factor completely, find GCF first, and then factor the remaining polynomial. From the first term and the second term, the number part, I can factor out the 3. From the variable part, I can factor the x. So we have x squared left, minus 1. Are we done? No, because the second part, this is the conjugate formula. That's the a squared minus b squared. What is the a? A is x. What is the b? B is 1. So x squared minus 1 squared. 3x times x plus 1, x minus 1. Let's see, next example. There are 4 terms. That means we can use group factoring. So factor the GCF from first 2 terms. I can factor the x squared. So x plus 2. Then factor out the GCF from last 2. I can factor out the positive 9 because I want to create a positive x. Then we have x plus 2. So factor out the GCF, x plus 2, then multiply by x squared minus 9. Are we done? No, because the second factor is x squared minus 9. 9 is 3 squared. So we can express it like x plus 2 times x squared minus 3 squared. Use the conjugate formula, x plus 2 times x plus 3, x minus 3. So we will factor it into the 3 factors. Okay, we're done for chapter 1.1. If you have any question, please let me know. Okay, see you next video.